So, but if we're solving this problem right here, and the question at the end says determine the identity of the gas, well, the thing about the gas that's in this table is molar mass, and you can calculate molar mass using the ideal gas law. Okay? All right, so the ideal gas law is on your test references, and you should probably know it. We've used it enough. Let's see, where is it? PV equals nRT. Okay? PV equals nRT. Molar mass is not in that equation. All right? However, there's also another formula on your test references that will help you get there, right here. And it says that moles, that's what the small letter N stands for, is equal to mass over molar mass. You need to know the capital M stands for molar mass. Okay? If I plug in this for the N in the problem here in the ideal gas law equation, and then isolate molar mass, get it by itself, just like we learned to do in that unit where we were doing molar gas law calculations, you can solve for molar mass. If you're still struggling trying to get your equation into a form you can actually use, and we're plugging in the value N, which is mass over molar mass. N is moles. Plug it in there, okay? And then we want to get M on the top. You can't solve for molar mass when it's on the bottom. Nothing can be solved on the bottom of a fraction. And so I multiply both sides by capital M over little m, and that allows me to cancel out M over M here, okay? And then we get to this, okay, where we have capital M over little m times PV over 1 equals RT. And then I'm going to try to get rid of everything but the capital M. So I use PV on the bottom and mass on the top. That's what I put here. Mass on the top, PV on the bottom. Mass on the top, PV on the bottom. That allows me to derive this equation. Molar mass equals the gas constant times the Kelvin temperature times the mass over the pressure times the volume. And you just plug it in. Yeah, I'm sorry. So molar mass times the gas constant times the Kelvin temperature times the mass over the pressure times over the volume. Okay? So this is just algebra, okay? You have to be able to derive this equation from these two things which are given to you on the test references. All right? It's pretty straightforward algebraically. Okay? Now, if you need help with algebra, you can come see me. I'll help you with algebra, but this is pretty straightforward algebra. Okay, remember your temperature has to be in Kelvin, so you've got to convert that to Kelvin. All right, you did that? Okay. So the mass is 2.30 grams. Okay. R, we're using the gas constant that contains atmospheres. That's on your test references. Gas constants are listed right here. Okay, 0.0821 liters atmospheres over moles over Kelvin. Okay, and then you got your temperature in Kelvin, 297.5 K. And then by putting you got to put that over the pressure. So I just do an inverse for pressure here and an inverse for volume here, just to make the math work out nice and easy. Okay, I've taught you to do that before. You don't have to. You can put that over those things and then invert and multiply, and you'll end up here. So you cancel everything you can cancel, and you end up with grams per mole, and that's what molar mass is measured in, grams per mole. Rounded off answers, 28.1 grams per mole. We look at the chart, and we see that the answer that comes closest to 28.1 grams per mole is nitrogen. Does that make sense? All about plugging in, keeping it neat, making sure you use dimensional analysis and canceling the units you can cancel. If you're neat and careful, you can get the right answer. If you're taking shortcuts or leaving things out, you're going to get a wrong answer. Okay? So the idea behind my system for making you do things neatly and canceling everything and keeping it straight all the time is that you get so much practice with it in this class that you don't need it later. And you can take shortcuts later. But until you can do it this way, the complete way, taking shortcuts is going to give you the wrong answer every time.